Hello friends, welcome to Sankalp. Today we'll be learning about genetically engineered insulin. And by learning about genetically engineered insulin, we'll understand about the entire basic of biotechnology. Now what is the function of insulin? As we have heard from our very tiny school days that insulin reduces the blood glucose level or insulin decreases the blood sugar level. Now in our pancreas there is both exocrine part and endocrine part. As pancreas has both exocrine and endocrine part, we call pancreas as a mixocrine gland. Now the endocrine part of pancreas has many glands in it, and one of such glands is called as the islets of Langerhans. It gets accumulated into tissue, and that tissue is called islets of Langerhans. Now in the islet of Langerhans there are three cells: alpha cell, beta cell and delta cell. Among that, the beta cell of islets of Langerhans of the endocrine part of pancreas produces insulin. What it produces? It produces insulin. And what is the function of insulin? With the help of insulin, sugar, that is blood sugar, in presence of insulin is converted into energy. Okay, so the sugar of the blood enters into the cell in presence of insulin. अगर इंसुलिन नहीं होगा तो the sugar in the blood will accumulate, so blood sugar level will increase as the sugar in the blood will not be able to enter into the cell. Like what we see in an ocean. What we see in an ocean, that there is water everywhere, not a piece to drink, because the ocean water is filled with salt and we cannot drink the salt water. So पानी तो है लेकिन पीने वाला नहीं है. Similarly इधर भी क्या है, शुगर तो है लेकिन वो शुगर सेल के अंदर नहीं जाता. That sugar remains in the blood and it increases your blood sugar level. Am I clear? Now if a person cannot produce insulin or have any mechanism where insulin cannot enter into the cell, then the blood sugar level will rise, and when the blood sugar level rises, then we call it as diabetes. Now diabetes is a separate topic of discussion and we'll discuss about diabetes in our subsequent videos, but here let's understand in details about insulin. Now there were, in the earlier time, in the 1920s to 1960s, what happened? Insulin that we generally consume came from either cattle or pigs. So in the earlier period, in the 1920s to 1960, in that period, the insulin that we use for diabetes, that insulin generally came from the pancreas of the cattle or the pancreas of the pigs. But we all know that our body's insulin is structurally different from the insulin of the cattle or the pig. And we know that our body has a property of self and non-self. Whatever is inside our body, we consider it as self, और जो हमारे body में नहीं होगा, we consider it as non-self. Now suppose I taken a foreign insulin of a cattle into my body, then it is bound that there will be some hypersensitivity reaction. There will be reaction against that insulin by my body, thinking that it's a foreign body that came to attack us. That's our basic immunity, right? So whenever a patient taken that insulin that is extracted from either a cattle or a pig, then hypersensitivity reaction tends to occur. Now generally the site of entering an insulin injection is near our umbilicus. Yes or no? In a radius around the umbilicus, we generally take the insulin injection. Now while taking the insulin injection, there is tremendous pain, there is rashes, there is inflammation. So such type of hypersensitivity reaction seen. Then what scientists thought? Then scientists thought that क्यों ना हम insulin बनाएं with the help of microorganism. Now let's see what the magic they had did. So they had isolated the beta cell gene. They had isolated the beta cell gene and then cut that gene with the help of restriction into nucleus. They cut that gene with the help of restriction into nucleus. So with the help of restriction into nucleus, they cut the beta cell gene, and what they had produced, they produced the desired DNA. They produced the desired DNA. Suppose the desired DNA looked like this. And now they've taken a bacteria. What they taken? They've taken a bacteria. Suppose मान लो that this is the bacteria, and we all know that in the bacteria there is presence of its own DNA, and also there is presence of an extra chromosomal DNA, and that extra chromosomal DNA is called plasmid. So what the scientists did? Scientists had extracted that plasmid. Scientists had extracted that plasmid. And with the help of same restriction in the nucleus, scientists cut that plasmid. What scientists did? Scientists cut that plasmid. Now the plasmid is already cut, right? Now this cut fragment of plasmid is called disarmed plasmid. It is called as disarmed plasmid. So this cut fragment of plasmid is called disarmed plasmid. Now what the scientists have done? With the help of the enzyme ligase, scientists have attached with this disarmed plasmid, they had attached the desired DNA. What they had done? They have attached the desired DNA. Yes or no? And what they had called it? They called it as rDNA, that is recombinant DNA. What it is called? Recombinant DNA. Yes or no? What they call it? Recombinant DNA. Now what had the scientists did? They had put that recombinant DNA into the body of the bacteria. So what they had done? They had put that recombinant DNA into the body of bacteria and allowed the bacteria to grow, allowed the bacteria to reproduce. Now we all know that bacteria reproduce in a very fast rate, from 1 to 2, from 2 to 4. Now as the bacteria reproduce, as the bacteria keep on reproducing, their genetic material also keeps on replicating. The plasmid, which is a self-replicating thing, also keeps on replicating. Now how the number of times the plasmid replicate, it will undergo transcription and translation and it will produce protein. Now what protein the plasmid produce? The plasmid produce nothing but insulin. Now what the scientists did? They have extracted the insulin, they had tested the insulin, they had packaged the insulin, and they had marketed the insulin. And that's how you get the insulin in our day-to-day life. And that's the application of biotechnology, by with the help of the microorganism we can produce so large scale production in a very small time and in a very cost effective manner. And that insulin that the scientists had produced is very much cost effective, don't have any hypersensitivity reaction in comparison to the insulin that is produced from a cow or that is produced from a pig. Am I clear? But there is a problem here. What is the problem? The insulin that is produced is a pro-insulin. The insulin that was produced is a pro-insulin. Now what do you mean by pro-insulin? By the term pro-insulin, we mean inactive insulin. By the term pro-insulin, I mean inactive insulin. Now what do you mean by inactive insulin? By the term inactive insulin means it cannot exert the effect that it tends to occur. So जो effect करना था, that is to reduce the blood sugar level, it cannot reduce the blood sugar level as it is expected to do. Now why? Because generally insulin has 3 polypeptide chain. How many polypeptide chain it has? it has 3 polypeptide chain. So generally insulin has 3 polypeptide chain, 2 shorter polypeptide chain and 1 longer polypeptide chain. Suppose this is polypeptide chain A and this is polypeptide chain B. Now this A polypeptide chain has 21 amino acid and this B polypeptide chain has 30 amino acid. Now connecting this A and B polypeptide chain, there is a C polypeptide chain. There is a C polypeptide chain. So there is A polypeptide, there is B polypeptide, and connecting this A and B polypeptide, there is C polypeptide chain. So C polypeptide chain helps in connection, right? Now this form of insulin is called as proinsulin. It is called as proinsulin. It is inactivated form of insulin. Now if you stretch this insulin in a linear manner, if you stretch it in a linear manner like this, you will see that. You will see such type of expression, right? There is A chain, there is B chain, and connecting this A and B chain, there is C chain. So this is A chain, this is B chain, and connecting this, there is C chain, right? Now this form of insulin is inactivated insulin. Now what is activated insulin? What the scientists have done, suppose this is A chain, this is B chain, and connecting this A and B chain, there is this C chain, right? Connecting this A and B chain, there is this C chain. Now what the scientists have done, they have removed this C chain. They have removed this C chain, and when the A and B chain get removed, then we know that polypeptide chain has sulfur containing amino acid, right? Polypeptide chain is nothing but protein. Protein is made up of amino acid, and what is the sulfur containing amino acid? Cysteine and methionine. So in the sulfur containing amino acid, disulfide bond is produced. What is produced? Disulfide bond is produced, and that gives stability to A polypeptide and B polypeptide. And this form of insulin is the activated insulin. This form of insulin is the activated insulin. Now this is the insulin that is required. Why? Because in raw form, proinsulin is synthesized, and proinsulin to get converted into activated insulin, it takes 3 to 4 hour time. Now if a patient had injected insulin and if it has to work after 3 or 4 hours, then his or her meal schedule will get disturbed. जिस टाइम में खाना चाहिए था, he or she cannot take the meal in that time. He has to shift the period of taking the meal. So it becomes very problematic for the patient to rely or to be convenient with this product. That's why came this new technique where the C chain is removed and this form of insulin is produced. So look at this. Now what I got? Now I got activated insulin. तो साइंटिस्ट सोचा क्यों ना हम डायरेक्ट एक्टिवेटेड इंसुलिन बना लें, हम क्यों प्रो इंसुलिन बनाए, and that pro insulin will take 2 to 3 hours time to get converted into activated insulin. So let's build the activated insulin. So what the scientists had done, scientists had collected the gene of A polypeptide and also collected the gene of B polypeptide. Okay, scientists have collected the gene of A polypeptide and also collected the gene of B polypeptide. And what they did, they inserted that gene into the body of E. coli. Suppose this is E. coli 1 and suppose this is E. coli 2 and suppose this is E. coli 2. Now E. coli 1 produces A polypeptide, yes or no, and E. coli 2 produces B polypeptide, yes or no. Now when this A polypeptide and B polypeptide is produced, suppose this is A polypeptide and suppose this is B polypeptide. Now when this A and B polypeptide is produced, they brought this A and B polypeptide together, and when this A and B polypeptide together came, then disulfide bond is produced. Yes or no? Then what happened? Automatically disulfide bond is produced, and after formation of disulfide bond, these two polypeptides gets converted into mature insulin. Yes or no? They got converted into mature insulin. Now this mature insulin for the first time was produced by a company named EDDD. Okay, this mature insulin for the first time was discovered or was first time invented by a company named Insulin, and that came in NEET. Okay, and this genetically modified human insulin has been given the name Humulin. Okay, so this genetically modified human insulin has been given the name Humulin, and that's how genetically modified human insulin is produced. And this insulin is very convenient to use, works instantly, and there are different forms of insulin that we learn in your graduation in your MBBS life. And so this is the basic concept that you have to know about genetically modified insulin, and if you know this concept, the entire biotechnology will be very easy for you. Thanks for watching. I hope you find it useful.